Today's 0 point quiz has solutions I'm going to go over right now that will allow you to get a score out of 39. This first problem wants you to take these values and put them into graphical analysis. So you can cut and paste them. You see I did that right here. I did a curve fit that was linear, which gave me this linear regression model. The linear regression model gave me a slope of 1.5 and 2. So I went back to this. That's where I got the slope of 1.5 and 2. That is worth 1 point, getting these correct values. The models, like we've been doing for the last few weeks, we'll start with the graphical model, always have to have the following characteristics because that's what we look at when we compare different graphs. And these are just abbreviations of what we have here. I could do a screenshot, but there's so much information here. Sometimes we just want to get rid of all the periphery and just get right to a quick sketch. It's a little bit easier to look at, and especially if we're going to be drawing on whiteboards and things like that where we can't do cut and paste of screenshots. So we want to have position and time. That's the label on each axis. We want to have the units on each axis. That would be meters and seconds. We should have the maximum values that provide a little bit of scale for us. That would be 18 and 29 are the max values. And then we should show the trend line or curve that we chose. We don't need any points. We just need that straight line curve that I see here in red. For the mathematical model, we're taking the regression model, which would be the y equals mx plus b form of the equation of this line, that linear equation. And we're going to replace the x and y in y equals mx plus b with a variable that represents what's being plotted on the y and x axis, namely position instead of y, so that position is the letter x, and instead of the x-axis value here, we're going to use t for time. Okay? The slope and y-intercept values, if you got them wrong, that would lose a point here, but this is grading the substitution of those values in to our mathematical model, and this mathematical model is now done. We also want to write the slope as a fraction with units, so I'm going to do that right here. 1.5 over 1 is writing as a fraction, and we got to make sure the units coincide with rise over run, so that would be meters over seconds. Number 2 is a review problem. In this group they did 1, 7, and 15 meters for different heights, and then they measured the impact force, which they didn't give us. They dropped it 5 times for each of these heights. So they did repeated trials. The maximized range is pretty good, it's 1 to 15, but they only did 3 different heights, so that was a weakness. There's 1 point for each of those. I'm not necessarily grading the frowny face here, it's just did you evaluate it based on these 3 criteria. In terms of this graph, we're going to be trying to get the velocity values for each of these segments of constant velocity, and then plotting that as a y-axis value constant on this graph. So I'm looking to get the slope of this first segment, which is going to be 3. I can do that by going, for 1 second, it went up 3. Or I can take the overall 12 that it went up over 4 seconds. 12 over 4 is 3. So I plotted that value 3 for the first 4 seconds. And just be careful of the scale on this, right? This was 1 through 15, each individual box was 1. Here, every box is 2. So be careful. This was going to be then a slope of -2. So I plotted -2 and so on with 0 and -1. Doing the opposite, starting from a velocity time and going back to position time, one of the key confusion points here are where do we start? So we can always just start at 0, but it doesn't matter where you start. What matters is what we do from there, meaning the slope. So we have a slope of 4. So I did up 4 over 1, up 4 over 1 for the first 2 seconds. So that's going to give us at 8. Some people like to just do area under this curve, which would be 2 seconds times 4, and then say, okay, after 2 seconds, they're at a position of 8 away from where we started. So I would just put a little dot here at 8 and connect it with a straight line. We're going to then have a speed of 0, which means wherever we are, we're going to now have a flat line because we want that slope to be 0. Okay, then leaving where we left off right here, the speed is going to be 2. So that means we're going to go up 2 over 1, up 2 over 1, Or again, we could have done area and gone 4, which tells us then after 2 seconds, we would have gone up 4. Same thing for -3, we're going down 3 over 1, down 3 over 1, and so on. For this question, we're asking which object is fastest after 1 second. Because it's a velocity time graph, these are literally the velocities. So 8 is greater than 5. So A is going to be faster at the 1 second mark, which is right here, than B, which is traveling at 5 meters per second. Part B wants to know which one's farthest behind after 5 seconds. So we could do an equation here, but the idea is we need to calculate the delta x for each. Okay, when you do, you realize that A is only moving for 3 seconds. So in moving 8 meters per second for 3 seconds, it ends up going 24 meters. And then it's just stopped. B is going 5, but it's going the whole time. So if it's going 5 meters per second for 5 seconds, it's going to go 25. And therefore B is farther. In this problem, we have to first convert anything that's not in standard units into standard units. So 20 miles per hour is the same thing as 8.9 meters per second. That's using the conversion factor at the top of the test, which would say that 1 mile per hour is 2.24 meters per second. So I'd be dividing 20 by 2.24 to get to this answer. That's worth 1 point, as you can see here in the rubric. Then we're going to show the equation, right, in all letter form. That's on a point. That's 1 point there. Then we're going to do substitution. So we're going to substitute in that speed, that velocity of 8.9, and the time of 5. That allows us to get an answer in standard units of 44.6 meters. And I can simply convert that answer into feet using the conversion factor that's at the top of the test. That is, for every 1 meter, there's 3.28 feet. So I'd be multiplying 44.6 by that 3.28. In this problem, we have a person running 40 yards in 5 seconds at a constant speed. Assuming they could run that same constant speed, but instead for 100, how much time would it take? You could set up a proportion with this to solve for it, but I would like to, again, use the rubric that it has here. So we're going to first convert 40 yards into standard units of meters, 36.6. I'm going to then use the equation, substitute in values, and get that speed of 7.3, which is going to be the same speed that they're going to then run 100 meters for, and that will give you a time of 13.7. So I'm grading the conversion, the use of this equation, the substitutions of delta x and time, and 100, and my speed from the previous part, and then the correct answer of 13.7.